As you can see, I'm lifting these weights effortlessly. But how do I do it? How does my brain communicate with my muscles? Well, the brain communicates with the body's muscles through neurons. When you and I decide to move a muscle, a motor neuron in the spinal cord fires. This bioelectric impulse is called an action potential. The action potential travels from the spinal cord all the way to wherever it's needed through a part of the nerve called an axon. The action potential will travel along the axon and to all the motor neuron branches. Each motor neuron branch affects a different muscle fibril. However, because they're all controlled by the same main motor neuron, they are all grouped together and called a motor unit. All muscles in a motor unit have to be used at once, and that is called the all or none principle. All branches in a motor neuron end in a neuromuscular junction. When the action potential finally hits the neuromuscular junction, acetylcholine is released into the synaptic cleft. In the synaptic cleft, acetylcholine binds to the acetylcholine receptors. This causes action potentials to be activated in the sarcolemma. The action potentials propagate through the sarcolemma and cause T tubules to open. Calcium within the T tubules diffuse within the sarcolemma and bind to troponin. This causes troponin and tropomyosin to uncover and reveal binding sites in the actin. These binding sites allow myosin to bind to them in a process called cross-bridge binding. ADP and phosphate on the myosin head give the myosin energy to power stroke and slide the actin filament past the myosin filament after cross-bridge binding. Once complete, ATP binds to the myosin head and reset the myosin. After being reset, ATP breaks down to ADP and phosphate. If calcium ions are still bonded to troponin, the binding sites will still be open, and the process resets. All of that was part of muscle contraction. As you can see, the process of cross-bridge binding and power stroking has slid the actin and myosin filaments past each other. At the end of the process, the actin filaments overlap, H bands are gone, I lines get narrower, but the A band stays the same. This is how our body moves muscles.